Hello friends and my dear students, as we came to the third session of this product architecture, in this we will see what is modular design and what are the clustering methods. Basically, modular design, you will see this is a one method which is called as basic clustering method, in which what you have to do, first of all, create a function structure of a product, means what are the different functions of this product that you have to list it down. Now then cluster the elements into the module chunks. You have to cluster the elements in the module chunks according to the function structure. Then create a rough geometric layout on paper, means this is a kind of 2D geometric layout. You have to draw that how this will relate, one element will be related to other. Then define the interaction, how it is interacted, one element or one cluster or one module chunk is related to other, and detail performance characteristics, how it will work after relating to the one another. So that I have to list it down, and this is the whole procedure of modular design according to the basic clustering methods. We'll see one by one. Now as in the first part of this, create a function structure of a product, which is function structure is input and output diagram of the product, means how what will come as an input in this part and what will go as output of that part. Okay, so input and output can be materials, energies and signals that we will see in the next further slides. And a fully connected set of blocks result into a suitable structure for analysis. Okay, if your blocks are fully connected, then that will be suitable for your structure of for analysis. Okay, now in this part, which you have to cluster the elements into the module chunks, means you have to cluster the specific or same characteristic elements into a module chunks. Okay, these chunks will become the modules or assemblies or assembly of the products, or these are called as sub assemblies. Chunks are chosen based on the natural or intuitive groups of sub function that are depends on each other or can be solved together. Okay, overall process of identifying chunks is known as clustering. This method is called as clustering, and how you can solve according to the function, or maybe depends on natural and intuitive group of sub functions. Okay, now create a rough geometric layout, means you have to draw a block diagram of a product module, and two sub steps to embody this activity of modular design is create a hierarchy of product architecture from function structure chunks. Okay, and map the hierarchy to a 2D, mostly 2D, and sometimes if you have a good hands-on on 3D sketch, then you can draw a 3D sketch of the product layout. Okay, with the help of these two steps, you can prepare your rough geometric layout. Okay. Now define the detailed performance characteristics. There are four types of interactions which we have identified or which you have to investigate, which are number one material interaction, which is solid, liquids or gases that flow from one module to next. That these solid, liquid, gases flowing one place to other or one module to other, that is called as material interaction. Next is energy interaction. There are various energy that are transmitted from one place to other, like electrical energy is converted into mechanical, or mechanical energy is converted into electrical. So there's energy interaction you have to investigate. Next is information interaction, which is signals that must be processed from one module to other. Signals can be tactical, acoustic or electrical. So that information interaction, so you should also look after. Okay, next is spatial interaction. Spatial interactions are geometrical dimensions, degree of freedom, tolerance, constraints that must be maintained between the modules. So these are the things which you have to look after for the interaction of the interaction point of view between the modules or the elements in the modules or module chunks. Now modular design and advanced functional method, which is the second method or the final method of modular design. In this there are few different methods or which subheadings, sub parts of this functional methods are function dependency, module heuristics, dominant flow and branching flow. Okay, so creating a module based on the product family, what you have to do, decompose the product into their representative function, develop modules with one to one. Okay, then group common functional modules into common product platform, standardized interactions. So this is your common function, you have divided it into some specific functions. Then these are the derivative products. Okay, these are the common functions, the specific function, and this is derivative product number 1, 2 and k. So this is called as product family and this is called as product platform. Okay, so with the help of this you can also generate some module based product family. Okay, now this is the example of brown family of coffee makers. Like, this is your basic model. This includes water filter, this includes thermos carafe, auto shut off and clock. Okay, this is adjustable filter, means there will be adjustable filter. This is frothing agent. As you can see, there are various number of vehicles are coming, like Pulsar 2002, 2005, 2010. So these are the series or a product family. You are doing some modifications, means you are just adding some specific function with the common function, and then you are ready with some derivative or other or next product of that series. So this will give you, this is your whole common function which we have already discussed in the previous lectures. So this common function is common, and then you are added some this is your basic model, you have added bottle filter, then this will become a next model. So this is the whole series of coffee makers, or you can say this is a product family of coffee makers. Similarly, there are product family of vehicles, product family of two-wheelers, and many more. Now this is a dominant flow. In the dominant flow, which is examine flow through function structure, and the sum function through which these flow are traced are defined as a module, means you have to check the flow from one function to other. And similarly, in the branching, examine flow that branches into it, converges from parallel function chain. You have to see the parallel functions chain and only focuses on branches. Okay, each branch of flow can become a module, and module interfaces at a point where flow branches or converges. Okay, and convergent transmission, examine flow. This is a last or second last method of this modern product development or module design phase, which is examine flow that converted from one type to another, develop our module which converts an energy or material flow into another form, then transmit it. So this is called as conversion and transmission. So an architecture based development team, okay, what the team will do, it will decompose system on function level, apply the module heuristics, associate ungroup subfunction, and assign team to develop modules. Okay, means individual team will be there to develop one specific module, and after development of the specific module, the overall team will combine all those developed modules or chunks, and this will give you the whole product. Now, as we came to the final of this product development or product architecture phase, so these are few fundamental decisions which one should take, like your modular or your product architecture will be integral or modular architecture, and what are the types of modularity, how to assign function to a chunks, means how to decide chunks on the basis of functions. Okay, how to assign chunks to a team, how you can assign chunks depends on their characteristic, their qualifications, their knowledge to the sustainable parts, or their knowledge to the specific function of that chunk, and which chunks to outsource, means what are the chunks which you should not manufacture inside your industry, which you have to purchase it from other outsourcing elements or outsourcing vendors. Okay, so these are the some fundamental decisions which we have to take look after during your product architecture design. Now, architecture choices define the subsystems and modules of the product platform of the family. Okay, architecture determines ease of production variety, means it will create some easiness in the production. Okay, and feasibility to customer modifications. System level production cost is also very less, and key concepts are modular versus integral architecture, and clustering to chunks, and planning the product families. Okay, now I will showcase you some pictures which are the elements of your case study of product architecture. This is a product architecture example of HP DexJet printer, and this is the printer, and this is the whole desktop or DexJet printer schematic. Okay, flow of forces, energy, flow of material is depicted by this dark line, flow of forces is depicted by more darker line, and flow of signals are depicted by dotted lines. Okay, so as you can see in the picture, these are the elements or functions like enclosed printer, provide structural support, printer cartridge, and this is the signals. Okay, so with the help of this, you can also draw your schematic diagram of your printer which you are having there at your home or office. And this is the cluster elements into chunks. We have clustered, means these are the functional elements in the black, and the orange this is chunks. So this is a whole chunk. Okay, this is a whole chunk. Okay, this is a user interface board, so this is a whole chunk. power cord and bricks, this is a whole chunk. This is logic board, so this is a whole chunk. Okay, so in this way we have clustered elements into chunks. Now this is your geometric layout which we have drawn. Okay, so this is your geometric layout. Like this will be paper tray, this is a print cartridge, user interface board, logic board, print mechanism. This is a whole 3D view of your geometric layout that we have developed. Now this is incidental interaction, means we have developed the interaction between different chunks or different modular sub-assemblies. Okay, so this will give you some idea about how you can develop the incidental interactions. Now planning for commonality table. What are the common? Means this is a family, this is students or Soho, small office, home office. Okay, so difference versus commodity, trade-off, product variety or production complexity. So you have to create optimum thing between product variety and production complexity. Okay, there are few other images. With the help of that you can also follow these steps. Which is, what are the steps we have followed? This is the whole picture. This is at the last when we have developed the product. Okay, first of all you have to draw the schematic with the help of these functional and physical elements, convert cluster elements into chunks, then geometric layout, then find out the incidental interactions, then find out the commonality table, means what are the differences and common points between the different chunks, then assemble it, and that will give you the whole part. Now I'm showcasing few images. You can also develop your product architecture or follow the product architecture process to develop the whole new version of that product. Go through it and follow. This is a product architecture of a limb. Okay, these are the slot modular architecture, bus modular, and sectional modular. This is a combination of two things which we have already studied. Then this is a same print cartridge thing. This is a cluster. These are the sectional view. This is your incidental view. These are the some early deformation and postponement, how it will develop the things that you can see. These are the things. So as of now we are stopping our discussion here. So in the next lecture we will see another topic of product development and launching, which is a 8 semesters syllabus of mechanical engineering students in the Rajasthan Technical University. Stay tuned with our Engineering College Banswara YouTube channel for more such updates and more information on different branches of engineering. Thank you so much.